right? Simply here that ray reflects back, right? So here we will follow the laws of reflection. Angle of incidence is equal to angle of reflection. So here angle of incidence is something I. So reflected angle is what? Angle of reflection. So it is exactly equal to angle of incidence, right? Angle R is exactly equal to what? Angle I. So this is law of reflection. So both are here equal. So that we will follow, right? So simply that can be applicable for the spherical mirrors or not. That is the confusion topic for us, right? So let us see that reflection by the curved mirrors. Nothing but concave and convex mirror only. So here, for the concave mirror, we can use the symbol as you see on the screen. So here, convex surface is shaded and concave surface is reflecting surface, right? This is what? Reflecting surface, right? This is opaque surface. So opaque surface is convex surface and reflecting surface is concave surface. That's why this mirror is concave mirror, right? Then look at this another one here. Before going that, I'm incidenting a ray of light. Then what happens? Can you expect? Anybody? Right? So here it is also going to be reflect. But my question is that law of reflection will be applicable or not? If applicable, which is used as normal here? There are two problems. It obeys laws of reflection or not, and if it is obeying the laws of reflection, what will be the normal? Which is act as normal for it, right? So there are two problems. So look at the right mirror. Here, which surface is opaque? This is opaque. Opaque surface is concave, right? So concave is opaque. Next, what about convex? Convex is reflecting surface, right? Convex is reflecting surface. Then what happens if you incident a ray of light? So there will be a same problem. Law is applicable or not? If it is applicable, where we have to draw the normal. How to draw the normal? Because it is a curved surface, right? Simply if I draw a normal, will it be 90 degrees with the curved surface? Anyone answer for this one? I drawn a normal to the curved surface. Will it give you 90 degrees angle with the curved surface or not? Anyone? Anyone? Are you there? Vikrant, Rohit, Kaushik. No, it will not give you 90 degrees angle. So this line, what we expected, not act like normal for this. So something we have to think differently here. In case of curved surfaces, very easy to draw normal for the plane surface, but somewhat difficult in drawing normal. So we have to make it easy, right? We have to make it easy drawing the normal for the curved surface. That means for concave mirror or convex mirror, how to make it easy. So that purpose, we are depending on the mathematical procedure, right? So we will go for mathematical procedure. Then only you are able to measure the angle of incidence and angle of reflection depending on the normal. Because angle of incidence is what? Angle made by the incident light ray with the normal. And angle of reflection is angle made by the reflected light ray with the normal. So here, how do we identify the normal for a curved surface? So this is the topic for us. Let us see, right? Here, simply before going that, we are discussing about the activity 1, that which help us to finding the normal to a curved surface. If you have a textbook with you now, just open the page number 2. You will see that, right? So that activity now we are performing here. So for that, what we required here, we required simply a foam which is flexible to insert the nails and to bend, right? Or you can use rubber which has something thickness, or simply sole of your chappal, footwear, right? Anything you can use. That is required material, and we require nails, right? So here simply I taken one sole or a rubber, anything you can imagine. Then what to do? Here it is what simply rubber or thin foam, how it is looking like. That means I am asking exactly about the surface. What type of surface is this rubber or thin foam? Anyone? What type of surface is this?
Plain, sir.
Plane. So this is what? Plane surface. So for a plane surface, it is easy to imagine normal, right? Normal is what? It is an imaginary line at a point which is perpendicularly imagined to the surface or the plane, right? So here, as a line, I am using the nail. So I'm going to fix the nail on the surface of the foam. Plane surface. Foam is what? Plane surface. So perpendicularly, I'm placing the pins vertically. So look at the pin inserted to the rubber foam. So how it is looking like, perpendicular or not? Is it perpendicular or not? Yes. So it is perpendicular. So like that, I'll take few nails. So how they are looking like? All are perpendicular to the foam. So pins are placed perpendicular to the foam. So that pins, can I call it as normal to the foam? The pins are imagined as normal for the foam or not? Yes. So we can imagine that pins are normals for the given foam. So there is no confusion to imagine or to use this pin as a normal for the foam. Suppose if I bent that foam inward or outward, what happens? Suppose this foam is bent inward. Suppose, look at my hand here, palm. So it is looking like plane. It is looking like straight plane. If I bent this inward, it look like this. If I bent outward, it look like this, right? So that we are doing now. So suppose if I bent like this, how do you feel? That pins, are they perpendicular to the surface? In the second figure, curved inward, bent inward. Are they perpendicular to the foam? Here I am asking. Are they perpendicular? Very good. No, they are not perpendicular. So we cannot call that pin size normals to this foam in case of curved surface, right? So here, how it is looking like? If you imagine as a mirror, this surface I am calling now as reflecting surface. Imagine this as reflecting surface. So which mirror can you imagine here? Anybody? Which mirror you can imagine? What you said?
Concave.
Very good. It is now act like concave mirror for us, right? If I bend in reverse direction, which mirror you will get? Right? Before going that, here I am drawing the line exactly along with the pin, as you see here, like this, right? I am drawing a straight line, right? So why, I will tell you. Here, if I draw a straight line here, what happens? They are all remains. How they are looking like? Parallel to each other. They never meet for any extension. Yes or no? They never meet. Here, if I draw lines for the concave mirror, which we imagined, what happens? Here, what happens? Can anybody answer? If I draw a straight line here for these pins, what happens? They remains parallel?
Sir, they all meet at a point.
Right. Look at here. What happens if I draw? So one line drawn for the second name, third name, fourth name. What happened? They are all going to meet at a common point. They are all going to meet at a common point. Right? Then I'm going to bend in opposite direction now. Look at here. Now it is exactly opposite to the previous or not? Yes. Here, which mirror you can imagine here with this? This is no reflecting surface. So which mirror we can imagine? It is what? Convex mirror. Convex mirror. Is it clear? Just we are imagining that form as mirror. So here this form is imagined as plane mirror. Then the second one we imagined as concave mirror. Then the third one we imagined as convex mirror. Right? Here simply, what happens if I draw a straight line in the forward direction towards reflecting surface side? They can meet? Do they meet? Anybody?
No, sir.
Never meet. Never meets. So here, at this place, what we can say? Converging. Because they are going to coincide each other. They can meet at a common point. If they meet at common point, we can say them as converging. Right? If they never meet at a common point and appear to separate from each other, the distance increases if you move away from them. Right? So they said to be diverging. They are said to be diverging here. So in this case, what I'm going to do is I will draw the lines in opposite direction, backward direction. See here. In backward direction, I'm extending the line. So in this case, what happens? In this case, also we can see they are coincides each other at a common point. Right? Are you clear? No one responding. Are you following? Any confusion? Yes. So here, in this case, directly they are going to meet. Right? In this case, we are moving in reverse direction, backward direction, we can call it as. Right? So in the backward direction, if they are going to meet at a common point, we cannot say they are going to meet. Here they appear to separate from a common point. Appear to separate a common point. So this common point in both cases, we can represent as its center. Right? As its center, we can call it. Right? So look at, I used 2 points there. So I'll clear all these written information. Right now, you are able to see them points. Look at this. Right? Here, in both cases, we can call it as center for them. We can call it as center for them. So here I am going to define one of that, because here it is what a curved surface, right? Here we can call it as a curved surface. So curved surface, two-dimensionally we can call it as curvature mathematically. So for that curvature, which is acting like center, this point in both cases, right? So here simply we can join that center and the curvature using a line. We can join them using a line. So only here up to this distance, up to the boundary. So in case of arc, it has something center. That center to the boundary, that distance you can call it as radius. So here, that radius here we can call it as radius of curvature. Radius of curvature. So that radius of curvature we are not using here. This center is there. So this center is acting like center for the curvature. That's why it is called a center of curvature. This curvature is also made from a hollow sphere, right? So the center of hollow sphere of which the spherical mirror is a part, because in the previous discussion, I shown a mirror is designed by using a hollow sphere. So we got this shape from hollow sphere. So it's a center only acting as center for the mirror. So that's why here we are calling center of curvature this common point. This center acts as center for the curvature. I think you will get a little confusion. Nothing to worry. Just imagine a hollow sphere that nothing but your tennis ball, right? If you cut your tennis ball at this place, you will get two pieces. So one of the pieces like this. One of the pieces like this, right? So here, if you imagine complete part, it has a center. This part also has same center. This is I am exactly explained. So center of curvature discussion is over, right? So here we are defining the center of curvature. Nothing but center of the curved mirror. So in that case, we can use the term center of curvature. Then we will go for the next topic. That is here simply how to draw the normal for the curved mirror, right? So that is by the idea of tangent. So what is tangent actually, mathematically? So for that, just we need to have something idea of geometry. So for that, I am using a circle here. So for that circle, we have a center, right? We have a center. So it is only act as center for the curve, any place, any area, right? So I imagine one point on the circle. At that point, I am drawing a line that which meets the circle only at one point using this one. So I'm drawing a line. So here, I'm connecting that point with the center using a dotted line. Now look at. So this is a line I drawn which meets only at one point. If you extend this line for any length, can it meet the circle other than this point? Never meets. So this type of line we can call it as tangent to the circle at that given point, right? So one more observation is there. If you connect this point with the center, this exactly makes the angle with the normal, normal not, this radii is 90 degrees. This line and radii having the angle between them at any side 90 degrees. Is it clear now? Use your quick reaction. Is it clear? So tangent is what? A line which meets the circle only at one point. It is external line only. It is external to the circle, right? And if you connect this point of coincides with the circle and center, that makes the angle 90 degrees. So this line we can call it as tangent, right? So our meeting will be end in 2 minutes or 3 minutes. After ending, immediately use the same link to join in the meeting, right? Okay, I'll join live again with this same link, right? So here I got, suppose if I draw the same line at another point, suppose I selected one more point on the circle at right corner, top corner, then using the same method, I'm drawing a line, then connect it, that point with the center, then measure the angle. See here, that angle exactly here, 90 degrees you can observe. This is what 90 degrees at any side. Is it clear now? Right here. So this is, we can call it as tangent. That at that point only, not all the points, because it is coincides with the circle only at one point. So that line at this point called as tangent. So how this dotted line is with the tangent? Perpendicular at this point. So this line at this point, we can call it as normal, right? This is only, we can call it as normal for the curved surface. So tangent is a straight line or that which we are drawn at a plane that touches the curve only at one point. If you extend it any length, it never meets, right? So that we can call it. So radius is always perpendicular to that tangent line to the circle. So here, if you see something curved surface, exactly it is also, how it will be? It is also perpendicular. Yes or no? That you have to imagine. Suppose here I am covering this one. I covered. So what happened? Is it looking like perpendicular or not? Is it looking like curvature or not? A part of circle is not nothing but curvature. So here at any point, that normal is nothing but radii. Only the radii of that curvature considered as normal. Is it clear, everyone? Which is act as normal for the curved surface? Everyone give your response or speak out if you have any doubt. Please give me your doubt. If nothing, use your response. So I think everyone is clear, right? So we got idea of normal. We got idea of normal, right? So we will go for the next topic here. Right? So that is what simply here for the curvature, we are having idea about the normal, right? For that, I am using a scale on the paper, right? So as you see on the screen, use a scale on the landscape paper. That means use your notebook horizontally. Then draw a line. Before that, just you have to select your compass with the radii 10 centimeters to draw a curve, right? Draw a curve as you see. So compass is open for the radii 10 centimeters. Now I'm drawing a arc using the this pin of that sharp edge of the compass, right? I center, right? Then cut the arc. So this blue dot is what acts as center for the curve, right? So I make this one of the surface of the curve as opaque surface. So which type of mirror is this? This is what? Opaque surface. Can you name the mirror?
Concave.
Right. So this mirror is what? Concave mirror. Because concave surface is acting like reflecting surface. Right? Okay. Now I'm going to identify a point on the curvature. That means here, I'll show you with the red color spot on this curvature, right? I want a midpoint. That midpoint I'm going to identify here, right? So that blue point is center for this curvature. Then I'm identifying center of curvature definition already given, right? So once again, look at the center of curvature definition here. The center of the hollow sphere from which a spherical mirror is made as a part is called the center of curvature. That is denoted by the center letter C, right? So here, center of curvature I got. Then geometrically, I'm going to identify a midpoint on the surface of the mirror, right? So you can see one more blue spot here. So this point we can call it as pole. What we can call it as pole, represented by letter P. So how to define this pole? Pole is nothing. It is a point where we identified on the curvature, and exactly it is midpoint, right? So that midpoint we can call it as pole, the center of spherical mirror, right? On its surface, condition I am applying on its surface, right? That is called as pole. It is represented by the letter P. So now I'm using a scale to join the pole and the center of curvature with a line. So you observe, I drawn a line. I drawn a line. So this line I'm now calling as principal axis. What is this line? Principal axis. How do you define principal axis? It is an imaginary line that which joining or which passes through the pole and the center of curvature. This we can call it as principal axis. Is it clear, everyone?